Hello everyone and welcome to this presentation. My name is Slim Jallouli and I am Senior FAE at ST and I am the IoT and Cloud Applications Team Leader. Talking about IoT, we've all seen similar diagram before where we represent nodes that either through a gateway or directly connect to the cloud. The nodes, here represented as a light bulb, will always run a sort of an SDK that allows them to connect and exchange messages with the server. Today we are talking about AWS, and the SDK that Amazon has selected is FreeRTOS. ST, we took the FreeRTOS SDK and we packaged it as X-CUBE-AWS. The main concern these days with IoT applications is not getting the device connected and exchanging data with the server. The main concern is security, and that includes secure provisioning, securing the device itself, secure the communication, authentication, and update the IoT device in a secure way. Security, however, is a shared responsibility that includes the infrastructure provider, which is AWS in this case, the SDK provider, which is ST, and the developer. Today, we'll focus on how security has been brought to X-CUBE AWS with the use of SBSFU and ST-Safe. First, let's start with the agenda. In the beginning, I'm going to introduce the STM32L4 IoT board, and then I will present the ST-Safe A110. Next, I will go through the device provisioning options with AWS IoT. After that, I will go through the details of X-CUBE AWS, followed by a live demo. Then I'll present the over-the-air updates, followed by a live demo. And also, I will have Alexa skill demo that works with the example projects that we will use today, and that you can have access to it at the end of this presentation. And finally, we'll finish with the conclusion. The new STM32L4S5 Discovery Kit is based on the STM32L4S5, which is running at 120 MHz with 2 MB of flash and 640 KB of SRAM. The board also includes ST-Safe A110, a Wi-Fi module, a low-power RF communication with Bluetooth and dynamic NFC tag, multiple sensors, and also multiple connectors. ST-Safe A110 is a highly secure solution that provides authentication and data management services. ST-Safe A110 can be integrated in IoT applications, smart home applications, smart city applications, consumer electronics. Its key features are authentications, secure channel establishment, for example, for TLS communication, signature verification, users monitoring with secure counters, pairing and secure channel communication with host applications. An IoT device has to be provisioned and registered with AWS before it can connect and communicate with the server. Amazon offers multiple provisioning methods that allow an IoT device to communicate with AWS servers. When you look at the different device registration methods offered by Amazon, all of them they require the following: a secure facility to install the certificate and the private key, a trusted user and an application to install the certificate and the key. The certificate and the key must be unique per device. Also, you will need to register a CA with AWS. In some conditions, the certificate and the key could be compromised. And also, the IoT device can only be registered in only one account, except in the case of the multi-account registration. So what is the solution to satisfy all these requirements? So with the ST-Safe A110, its ST-Safe is manufactured and configured in ST's secure factory. ST is your trusted user that installs the certificates and the key. The certificate and the key are guaranteed to be unique per device. You do not need to register a CA with AWS thanks to the multi-account registration feature supported by ST-Safe. The certificate and the key, they cannot be compromised because they are securely saved in ST-Safe. And also we support the multi-account registration. Also, ST-Safe offers brand protection and many more other features. Now, let's see how security has been brought to X-CUBE AWS with the use of SBSFU and ST-Safe. The X-CUBE AWS is an STM32 Cube expansion pack for AWS IoT Core. It's a FreeRTOS pre-qualified port for STM32L4S5 IoT board and passes IDT test. IDT stands for IoT Device Tester. It's composed of more than 100 tests that we need to pass in order to get the certification. Use ST-Safe to establish secure communication with AWS. Also includes a secure boot and secure firmware update and also over-the-air update. Let's go through the X-CUBE AWS directory structure. When you download X-CUBE AWS and extract it, it will look like this. So here we have the HAL and the CMSIS and the BSP drivers for the STM32L4 IoT board. Here we have ST middlewares. All the libraries are coming from ST and used in X-CUBE AWS. Here we have the Amazon FreeRTOS SDK. Here we have embed TLS that is used for all the encryption operations. Here we have the key management service blob. SBSFU is the secure boot secure firmware update and is used as the root of trust for X-CUBE AWS. Followed by the X-CUBE secure engine library, ST-Safe provisioning project, the demo that connects to AWS, and also the AWS tests that we use to run the IDT tests. To understand X-CUBE AWS security features, we need to understand how the memory is partitioned. So the flash in STM32L4S5 is split as following. So on the top we have SBSFU. It's used to authenticate the application before running it and authenticate and install new firmware. It always runs after reset. Also, we have the download image. It's reserved for OTA images received by the main application. Also, we have the image header that is used by SBSFU to authenticate the new image. We have the active image section. That's the main application that runs Amazon FreeRTOS SDK. The active image header is used by SBSFU to authenticate the main application before running it. And also here we have a swap area that is used by SBSFU during firmware updates. The secure engine library is part of SBSFU and is shared also with the main application. It runs under the firewall. It's used for all the encryption operations and to securely communicate with ST-Safe. Also, it contains the ST-Safe pairing keys that are used to securely communicate with ST-Safe. X-CUBE AWS uses multiple keys and certificates. The device certificate used to connect to AWS and it's unique per device. The device private key used to connect with AWS and also it's unique per device. The host MAC key and a host cipher key used by Secure Engine to securely communicate with ST-Safe. Also, we have a root certificate, OEM certificate, OEM intermediate certificate, a firmware signing certificate, and OTA certificate used by the main application to verify the received OTA image. As we've seen when we described the X-CUBE AWS directory tree, X-CUBE AWS used multiple projects. In the next slides, we will see the purpose of these projects. First, let's start with the ST-Safe provisioning project. ST-Safe is delivered with just a device certificate and a device private key, installed in ST's secure factory and guaranteed to be unique per device. ST-Safe provisioning project is used to load the host MAC key, load the host cipher key, load the root certificate, load the OEM certificate, and log ST-Safe A110. These operations have to be done in the field because the host MAC key and host cipher key should be diversified and known by the secure engine. The root CA and the OEM certificates are specific for each OEM, and also ST-Safe must be unlocked to allow you to customize it. Please note that default ST-Safe provisioning use the same host MAC key and host cipher key and root certificates and OEM certificates for all the devices. Customers must personalize it for their own final product. The secure engine is built in as a library for the following reason. First, it runs under the STM32's firewall. is shared between SBSFU and the main application and hosts the SD-safe pairing key that should be diversified in the field. SBSFU is used to guarantee a unique entry point after a reset, ensure a mutable code and is form the root of trust, enforce hardware security mechanism in STM32 like the readout protection, write protection, PC wrap, memory protection unit configuration, firewall configuration, and watchdog. Also enforce security checks and perform firmware image verification and authenticate the new firmware before um, running it. And also update the user application in a secure way to prevent any unauthorized update. Please note by default that SBSFU does not enforce any security, so that the user can still plug a debugger and debug his application. Security must be enabled in production context. In the following slides, we'll see how software security is enforced by X-CUBE AWS. After reset, SBSFU verifies the following. It verifies the device protection like readout protection, menu protection, unit configuration, firewall configuration, and any other security features available in STM32. Verifies the firmware signing certificate, verifies the OEM intermediate certificate, verifies the OEM certificate, and then use the firmware signing certificate to verify the active image header and the active image itself. And when everything checks OK, it jumps to the main application. The active image receives a new firmware using OTA. At this stage, the application image and the header are seen as a single blob. The active image verifies the received blob using the OTA certificate, then generates a reset to start SBSFU. SBSFU verifies the new image and the respective header using the certificate chain. SBSFU then swaps the active image and the new image, including the header, and then generates a reset. The normal boot process takes place as we explained earlier. SBSFU also includes a rollback mechanism in the case of the new image phase to start or if the update was interrupted during the update. As we have seen, there are multiple certificates, keys, libraries, and projects used in X-CUBE AWS, and they must work together seamlessly. To do that, we need to follow a strict order of project compilation. Building X-CUBE AWS should follow this order. First, we need to build the two image SE Corbin. This will include the SD-safe pairing keys and generate a library. It's called SE_Corbin. And then build the SBSFU. This will include the SE Corbin and generate the final SBSFU image. And then we need to add the OTA certificates in the main application. So that certificate is used to verify the newly received OTA images. And then at the end, build the main application. Now let's build our demo and register our device with AWS. To get the hands-on zip file, you can go to st.com/xcube-aws hands-on and click enter. And this will automatically download the zip file for you. So I'm not gonna do it now because I already have it on my computer. After downloading the pack, so you will find it under your download directory. So double click on it and then extract the pack to the C drive. It's very important to extract it to C drive. I'm not going to do it right now because I already have extracted it to my C drive. So now let's explore its content. So here we have the drivers directories. So these are the drivers for the SMT2 and the IoT board. Here we have our hands-on directory. So this is what we will be using today. Here we have the middlewares that coming from ST and Amazon and embed TLS. Here we have the projects, and also we have utility. Let's open the hands-on project. So here you will see there are multiple directories and files here. So we'll explore only a few of these directories. So the first one here is the documentation. So when you open there, you will find this presentation, the hands-on presentation, and also the custom Alexa skill that we have prepared for this demonstration, so you can do it on your own. The next one that we will use is the shortcuts directory. So here we have the shortcuts for all the files that will be used to configure X-CUBE AWS. Also here we have three scripts, so mainly we will be using these scripts. So these scripts, the first one will create and register your device with AWS. The second one is to upload our OTA image to S3 bucket, and the third one is to publish an OTA to our device. First, let's start by configuring X-CUBE AWS. So you need to go to the shortcuts and click on every single file to open on your preferred editor. So here I already have these files opened in Visual Studio Code. In the beginning, so we need to set the IoT broker endpoints. So you can find that in AWS. So when you go to AWS and you open your AWS account and you go to IoT core, select IoT core, and then here under settings, you will find your endpoint address. So you need to copy that and then go to the project and paste it. After that, you need to set your thing name. You need to make sure that you give a unique name for every device you have. And after that, you set your Wi-Fi SSID and your Wi-Fi password. The next thing is to set your OTA certificate. So the OTA certificate, it should be you can generate it using this one-time scripts. So you run these scripts in order, script 1, script 2, and script 3. And this will create a certificate and create a signing profile and create an OTA role in AWS for you. So after that, you will find this certificate under cert. So you will find here a certificate is called ECDSA cert.h. You need to open that with an editor. You need to copy it, and then you go open AWS OTA pal.c. You scroll down, and then you will find the certificate here, and you replace it with your certificate. I already have done that, so I'm not going to replace it for now. So here, let's check again. So we have our OTA certificate, and we have our broker endpoint. We have our thing name. We have our Wi-Fi SSID and our Wi-Fi password. So next, we need to open STM32 Cube IDE and build the projects. To open STM32 Cube IDE, so you can type STM32 Cube IDE and open it from here. So I already have Cube IDE already open. So next thing, we need to import the projects. To do that, you go to File, Import, Existing Project into a workspace, click Next. So you go Browse, so C drive, and then our pack. You go to Projects, the L4 Discovery Board, Applications, and then click Select Folder. And once you do that, you will have the 4 projects that we need for today. And then click Finish. So now we have all the projects being imported. Next step is to build these projects. So the first project is, as you remember during the presentation, we need to build them in a certain order. So first, let's start with SE-safe provisioning. So right click and click build. Okay. Next thing is to build the SE Corbin. Right click on it and click build. Okay, now it's done. Next is SPSFU. Right click and click build project. Okay, it's done. Now the last thing is to right click on the our demo, right click on it and then click build project. Okay, now our build process it's done. So we can see here we have the binary file. So now CUBE-IDE will continue with some scripts to generate the final the final image. Here we see the post build.sh, and that will finish building the main application, generates the header, and combine the image, the header, and SPSFU in a single binary file. Before going to the next step, I will go to documentation directory and open the hands-on. So the scripts that we are going to do to use today relies on an AWS AIM account and also requires that you install a few tools. So the tools, the required tools, you will find them in the hands-on PDF file. So here you will need to install CUBE-IDE. Also, you need to install SM32 Cube Programmer. You need to install Python, so you can get it from python.org, and also you need to install PySerial. The next thing is you need to install AWS command line interface, so you can find it here, and also you need to install OpenSSL. So the OpenSSL can be downloaded from this link. Once you download it and you install it, you need to make sure that OpenSSL is added to the path in your control panel. So the next thing, you need to create an IAM account in AWS. Today I'm not going to do that because we don't have enough time to do it, but here you will have the details on how to create an IAM account. And also the next thing, you need to configure AWS CLI, the command line interface, in order to create to use that specific account that you have created. So here we have the steps on how to configure AWS CLI. Now we have everything set up, our AIM account at AWS, our CLI command line interface configured, and also we have built our projects. The only thing that is left now to have our device connected and uploading data to AWS. So here you see my board. So you need to have it connected to your computer. So this is the USB port that you'll need to use to connect your board to your computer. And the next thing, the only thing you need to do is double click on the first script. So the first script now uploaded the st-safe provisioning binary and run the provisioning binary. So now our st-safe is provisioned in the board. So now this script is downloading your main the binary file that includes SBSFU, your main application, and the header all together. So here you see that the script is erasing the content of the flash. Okay, so now is verifying the flash content. Okay, so now everything is running okay. So now there is another script that is running here that is extracting the certificate and also extracting the thing name. All right, so now when we go to AWS, we go back, we go to click on thing. Here we can see our thing has been created. So all we need to click on our thing, click on activity. So let's continue to monitor the um, the activity on the board. So here we see that our board restarted. Okay, so let me put this here. There we go. So now our board is connected and sending data to AWS. Now we can go and see the messages that being sent by the board. We can go here to MQTT client. And here we can enter our topic. So the first topic is DT and then your thing name and then sensor data. So the board is will be publishing sensor data to this topic. So this is topic is unique per board, and what is different from one board to another one is the board name. So the board name, if you go to AWS credentials, so here is the thing name, and this thing name, whatever you put here, is going to be used in that topic that your board will publish to. So you see, okay, click subscribe, and here we can see the sensor data coming from the board. So the board will be sending the temperature, the humidity, and timestamp. So here is another data point is coming. Also, the board will be sending, you can subscribe to the shadow. So we have a shadow example. So subscribe. So here is the shadow. And whenever you press the button on the board, so a message is sent to the shadow to toggle the LED and report the LED state. The other topics that you can use to monitor your board activity is the board connected. So when you subscribe to it, a message will be posted here automatically whenever the board is connected. The other topic is the board disconnected. So again, here is the board name that you used in during your configuration, so you can subscribe to it. And also you can use you have the last will topic, so you can use it. So the last will is sent whenever the board is disconnected. So when the board disconnects, you can send a message when there is a unwanted disconnection of your board. Okay. Okay, now I will open Cube IDE. I will show you where you will find this demo file. So you go to expand the demo and under middlewares, Amazon FreeRTOS, demo, and then here we have the custom demo. So there are four different files. The first one is the custom demo. So the custom demo here, so this is the one that will run the demos. So here you can choose if you want to include the OTA in your project or no, if you want to use to include the shadow demo or no, or if you want to use the sensor demos or no. So you can click on that and you see here, so you can enable and or disable each one independently, and you can configure your custom demo. So the custom demo OTA.c, so this is the task that is responsible for receiving OTA images. The demo sensor, so this is the demo that is responsible of collecting the sensor data and sending the sensor data messages. And then the demo shadow, so this one is responsible of sending the shadow messages when you press the button, and report the LED state, and also receive the shadow messages and toggle the LED depending on the command. Okay, so next step, what we will do is OTA update. Now let's say that you added new features to your product, or you made some changes to make your product work better, and you need to update uh, all the products that are already being deployed in the field. So let's say here we have we did all changes and tested them and they are okay. The only thing that will be left, and it's very important, is to increase our application revision number. So to do that, you need to open the AWS application underscore revision.h and increase the revision number. So it's very important to increase the revision number, otherwise the update will fail. So here I will increase my revision number from 1.0.0 to 1.1.1. Save it. I go back to Cube IDE. The only thing that is left is to build my project. So while the project is building, so we'll go back to the presentation and show what is OTA. So what is OTA? So OTA is stands for over-the-air updates. It allows you to deploy firmware updates to one or more devices in your fleet. So FreeRTOS over-the-air updates makes it possible for you to deploy new firmware images to a single device, a group of devices, or an entire fleet. Deploy the firmware to devices as they are added to groups, or reset or reprovision it. Verify the authenticity and the integrity of a new firmware after its deployment to the devices, and monitor the progress of your deployment, and also allows you to debug failed deployment. So the OTA activity flow in SCM32 follows as the following. So let's say after you do the changes, you increase the firmware version, and then you build the project, and the IDE of your choice will generate a .sfb file, so either Cube IDE or IIR. So the SFB file generation is done automatically by the IDE, so you don't need to worry about that. After that, you need to upload that .sfb file to an S3 bucket in AWS, sign the image, and then create an OTA job. So the same thing in this hands-on directory, we have included the scripts to upload the file to the S3 bucket, sign the image, and then create the OTA job. So once the OTA job has been created, it's going to be picked up by the OTA agent running on SCM32 and download the image stream. After the image has been downloaded, the OTA will use the signing certificate that is embedded in the firmware to sign the image, and when the image is verified okay and authentic, it will set the new image state to new and then call SBSFU. So SBSFU will use the certificate chain as we saw earlier in this presentation to verify the authenticity of the new image, and one that is checked, SBSFU will install the new image, set the image state to self-test, and then jump to the new image. So the new image will be in self-test, and when the self-test checks OK, the image will set its state to valid and report that to AWS. In case of the self-test fails, so the demo will set its state to invalid, call SBSFU again using a software reset. SBSFU will detect that the current image state is invalid. Then it will revert the image state. They will revert the image to the old one and then call the old image, and the old image will report its state to AWS. So now let's go back to CUBE-IDE. Okay, we can see our CUBE-IDE finished building the new project. The only thing now that is left to deploy is the image is to upload it to S3 bucket, sign it, and create an OTA job. So first, let me open this command line window. I go back to the hands-on and use the second script to upload the .sfb file to the S3 bucket. So run it. So I will open Teraterm. So for Teraterm, you need to go to Setup, Serial Port, and make sure that you have the speed set up to 115 to 100, and in the Setup terminal to receive to auto. So here we see that our board is connected and exchanged the messages with AWS. I go back to the script, so I see that everything is done. So our SFB file now it's uploaded to AWS. The next thing is to publish the OTA job. So I'll double click on that. Let me select Teraterm again. So that script uses multiple other scripts, as we say here, that are present in AWS scripts here and the ST scripts. So these are used to build the commands and communicate with AWS to sign the image and create the OTA job. Okay. So now we see our OTA job has been created, and now we see this activity. So it means that our board now is downloading the new firmware stream. Okay, so now we can see that SPSFU started. So now we can see that SPSFU has checked the new received image, and here that SPSFU is installing the new image. So and here that SPSFU now is swapping the new image and the old image. Okay, so now our new image has started. Okay, we are connected to Wi-Fi. Here we go, and now our image is connected to AWS. So if we go here a little bit on the top, we see here that the new revision number is 1.1.0. Okay, and now our board is connected to AWS. Okay, Now let's continue with Alexa skill. So let me open my camera. So here is my board. I have Alexa app open on my phone. Alexa, open STM32.
Welcome to your custom Alexa application.
Turn the LED on.
LED is now set to on.
We can see that the LED is turned on. What is the LED state?
Sorry, I'm not sure what you meant.
Is the LED on?
LED is currently on.
Okay, I can turn off the LED by pressing the button. So we can see the LED is off.
Sorry, I'm not sure what you meant.
Is the LED on?
LED is currently off.
Turn the LED on.
LED is now set to on.
Is the LED on?
LED is currently on.
What is the temperature?
Temperature is 30. Humidity is 31.
So that temperature and the humidity that Alexa reported, they were coming from STM32 from the humidity and temperature sensor that is available on STM32. So if you are interested on that Alexa skill, so we have included that document in the documentation. So you refer to Alexa skill PDF and you will have all the steps to create that skill. Okay. So for the conclusion, today we showed you how to securely connect your IoT thing to AWS and the easy of use of the multi-account registration thanks to SD-Safe 8110 and that everything we use here we use script-based to make provisioning and OTA updates as easy as possible. So again, X-CUBE-AWS provides a qualified port for FreeRTOS and it's IDT tested. So we pass more than 100 tests in order to be qualified. You can get X-CUBE-AWS from ST on this link. And also we bring a high security thanks to SPSFU and SD-Safe A110. So you can get more information about SD-Safe in st.com/SD-Safe, and also you can get more information on X-CUBE SPSFU by going to st.com/X-CUBE SPSFU. If you need if you need more support on these packages, so you can go to st.com online support. Thank you, and if you have any question, please let me know.